Assalamu alaikum and good evening, children. Today we are going to do waves and their application. So this is my usual theory class. Okay, today I'm going to do it as a free session because I'm going to begin today the first physics chapter of your grade 11 syllabus. Okay, unit 4. Okay, so the heading is children, waves and their application. So we are going to see here today what are waves, what are the type of waves, and what are the applications of that. Okay, so there are so many uses of the waves that we use in our daily life. Okay, so first let's see what do we mean by waves. Okay, children, so waves means, children, something called as disturbance. Okay, now think, for example, I am saying your friend is studying. Okay, when your friend is studying, children, if you go and disturb, what would happen? Definitely he will get angry, no? Because he is seriously studying for O level. When you go and disturb him, he will get angry. So he will shout at you. Maybe sometimes he will come to hit you. Okay, so he will react for it, right? So because of you disturb him only, he is reacting for it. So just like that, children, if you make a disturb, that means if you make a disturbance in a medium or in a space, okay, so for that only, children, we called as wave. Simply we can say disturbance propagating through a medium or space. Okay, medium means, children, it can be solid, liquid or gas. Okay, it can be solid, liquid or gas. For that only we called as medium. Sometimes you can make a disturbance in the medium or else without medium. Without medium means you don't have anything in the space. Okay, for that only we called as wave. So simply I will repeat again. The disturbance propagating through a medium or space is known as waves. Okay, so I'll explain it by using an example. Okay, now let's take a water surface. Okay, so this is how the water surface will look like. Okay, now I am going to drop a stone. Okay, I'm going to drop a stone on this water surface. So now what will happen, children? You will be able to see. So if this will look like a center. Okay, that place where you threw the stone, it will look like the center, and it will form the circles like this. You will be able to see this. It will form a circle like this. Why are you getting that circle? Why? Because you disturb the water. Why did you disturb the water? How did you disturb the water? By dropping a stone, children, you disturb the water. So because of the disturbance, it has formed the waves. So that's why you will be able to see that circles on the water surface. Okay, this is one example. And the next example, children, let's take, there is a rope and you have tied one end of the rope. Okay, one end has been tied and other end is free end. Now what are you going to do? You are going to shake this rope by using that free end. Okay, so you are going to shake. When you shake the rope, children, you will be able to see like this, like you will be able to see like this structure in the rope. So that means the rope will give you like this flexible structure. So what is this? This is also waves, children, because you are disturbing the rope. No, you are moving the rope, you are shaking the rope, that means you are disturbing. So because of you disturb that in that rope, the waves are forming. Okay, so simply I can say disturbance propagating through medium or without a medium are known as waves. Okay, so these waves, children, they carry energy. Okay, they have energy. Now again, look here. Now let's take in the water surface, there is a plastic ball. Okay, already there is a plastic ball. Now there is no any movement in the water. Okay, now when you drop a pebble or stone in the water, I told you, no, they will form the circles. Okay, so in here, in that in this space also, you will be having that circle. Okay, that means they will form the waves. That circle means I'm talking about the waves. If you see the motion of the ball, children, it will move up and down. You will be able to see it will move up and again it will move down. It will move up and down. So because of you disturb the water surface, it will form the waves, children, and because of that waves, the ball will move up and down. You all know, if the ball is moving, children, definitely they should have energy. No, without energy, without having an energy, can that plastic ball move? Can't. They need energy. Then who gave them the energy? It was stationary only. After you disturb the water surface only, it has started to move up and down. That means, children, the water waves, the waves which formed in the water has given energy to the ball. That's why the ball is moving up and down. Is it clear? The ball is moving up and down because of the waves. Waves has given the energy. Okay, children. So, and another thing. So that is one main point. So you should understand always waves will transmit the energy. So the transmission of energy has taken place. That's why the ball is moving. And then other point, children. Now think the water waves are traveling in this direction. Okay, the waves are traveling in this direction. Now you have the water. No, the water will not travel. The particles of the water is there. No, it will not travel. It will just move up and down. Okay, it will just move. It will stay in the same place and it will move only up and down. Only the waves will travel. So this is another important point. Okay, waves will transmit the energy, but the particles of the medium do not travel along with the wave. Okay, children. Now, in the first one, I told you here our medium is water. No, so I told you we are disturbing the water. No, so our medium is water. So water is not traveling. Only the water waves are traveling. What happening to the water particles? It is moving up and down. So because of it is moving up and down only, I told you the plastic balls also move up and down. Is it clear, children? Is that clear? Okay. Now even if you take the rope, children, I told you tie the rope and shake the rope. When you shake the rope, what will happen? It will form ripples like this. It will form a ripples like this. Okay. So here also, does the rope is traveling? Can you see the rope is traveling? Did they get the legs to travel? No, they won't travel. Rope is staying in the same place, but only the waves are traveling. Okay, children, only the waves are traveling. Rope is staying in the same place, but the particles of the rope are there. No, it is moving up and down. So you should understand that. Okay, the waves has given the energy to the rope. That's why the rope is moving up and down. So here our medium is water. Here our medium is rope. Did you all understand, children? Do you all have any doubt? Did you all understand? Do you all have any doubts? Okay. Now, children, based on that medium and without medium, we can divide there are two type of waves. Okay, let's see what are there. The first one, children, the type of waves, the first one is mechanical waves. Okay, mechanical waves. And the second one is electromagnetic wave. Okay, mechanical waves means, children, if there is only if there is a medium only, they will propagate. If there is no medium, you won't get the mechanical waves. Okay, so through a medium, if there is a disturbance, if the waves are propagating through a medium, for that we called as mechanical medium. Without a medium, if the wave propagate, for that we called as electromagnetic wave. Now just think, children, from the sun we are getting the light and heat. No, how do we get that? How do we get that? Because that from the sun we are getting the light and heat that comes to the earth in the form of waves, children. So for that we don't need a medium. Medium means what? You don't need solid, you don't need liquid, or you don't need gas. So even in the empty space, okay, children, even in the empty space, these waves can travel. Okay, so likewise, so that is an example for electromagnetic waves. Without a medium, they can propagate. So for this mechanical waves, with the medium, mechanical waves means by using a medium, if they propagate, for that only we called as mechanical waves. Okay. Again, children, in this mechanical waves, there are two types. Okay. So first one is transverse waves, another one is longitudinal waves. So usually to identify the mechanical waves, children, in the lab, if you go to your physics lab, in a school lab, children, you will have something called slingy. Slingy means, children, it is made up of iron steel. Okay, so it is like a coil. It will look something like this. Okay, it will look something like this. For this only we call it as slingy. So by using this slinky only, we will identify the mechanical wave. So that means here our medium is that slingy is our medium. Okay. Now I told you there are two type of waves now in the mechanical, transverse waves and then the longitudinal waves. So let's see one by one. So let's see what is this transverse waves and let's see some examples for that. And then let's go to the second type of waves. Okay, let's start up with the transverse waves. Okay, children. For example, now I'm going to take a slingy. Okay, so this is the slingy. By using that only, I'm going to do the activity. Okay, now if now what I'm going to do, from one end, I am going to move the slingy left to right like this. Okay, I'm going to move left, right like this. I'm going to move. When I move it like this, children, they will form a wave like this. Okay, they will form a wave like this. Means you will get like this structure. Okay, like this, like ripples you will see. Okay, you will form like this structure. That means when I move it left to right, children, the slingy will move according to that. Okay, so that means, children, I can say now the waves are traveling in this direction. I'm moving the slingy left to right and the waves are traveling in this direction. So look here, children, particles of the slingy are moving left to right. No, left to right. The waves are traveling in this direction. So look here, I can say the particles are moving perpendicular to the direction of the wave. The waves are moving like this and the particles are moving like this. So perpendicular to the direction of the wave. So that's why we call that transverse waves. How the particles are moving? Particles are moving perpendicular to the direction of the wave. So for that only we called as transverse wave. So I told you in the water surface, children, when you make a disturbance, plastic ball, what did I tell? It will move up and down. So just like that only, water particles also will move up and down. Wave will travel like this and the water particle move up and down. So the water waves is an example of transverse waves. Just like that, children, I told the second example. If you tie a rope on one end and if you take the free end, they will form the wave like this, which means they will form the ripple like this. So in this case also, the waves are traveling in this direction and the particles are moving up and down. Okay, that means the particles are moving perpendicular to the direction of the wave motion. So this is also going to come under transverse wave. Is it clear, children? Did you all understand? Do you all have any doubts in this transverse wave, children? Simply like this. So the it's moving perpendicular to the wave motion. Okay. The second type, children, longitudinal waves. Okay, the second type is longitudinal waves. So this is transverse waves. So let's see what do you mean by longitudinal waves. So here again, I am going to have the slingy, children. Look here, I'm going to have the slingy. Now, in the previous one, I moved the slingy to left to right. No. Now what I am going to do, I am going to shake it, like I'm going to move it forward and backward. Forward and backward. Like this, I'm going to move. So when I move it like this, children, you will be, when I move it forward, the particles of the slingy is there. No? It will held together. Held together means like this. It will be very close to each other like this. When I move forward, okay. When I move backward, the particles of the slingy is there. No? there will be a big gap between the particles. See, here you are having a small gap. No, here you are having a big gap. Here the gaps are very small. Okay, so this is when I move forward, they will come together. They will held together. For this we called as compression. And here if I move it backward, children, what's happening? The particles are far away from each other. For this one we called as rarefaction. Okay, when I keep on moving forward and backward, you will be able to see compression, rarefaction, compression, rarefaction, compression, rarefaction. You will be able to see a picture like this. Okay, you will be able to see compression and rarefaction. Compression and rarefaction when I keep on moving forward and backward. Okay, so yeah, left to right means it is upside up like this. Now I am moving in this direction, left, right, like that. Now here forward and backward means like this. I am going to move forward and backward, forward and backward. So when I make a forward, the first time when I do a forward, children, it will make a compression. Okay, when I make a backward, that means I'm pulling it back, I will get a rarefaction. So when I keep on making that, when I keep on moving it like forward and backward, I will get both together. I will get compression at one place and I will get a rarefaction. Compression, rarefaction. So if you see here, the waves are traveling in this direction, and how is the particles are moving? Particles also moving in this direction, forward and backward, forward and backward. So here if you see, the particles are moving parallel to the wave motion. Okay, particles are moving parallel to the wave motion. So for this only, children, we called as longitudinal waves. So I told you transverse waves means particles will move perpendicular to the direction of the wave motion. Longitudinal means children, particles will move parallel to the wave motion. Okay, now I show you all a diagram, children. Look at that diagram. Look here. So this is longitudinal waves. See, they have given to you when you forward, when you move the slingy forward and backward, children. So forward and backward. See how the slingy look like. So here the particles are held together. Okay, so this is compression. And here if you see, particles are far away from other, right? So that is rarefaction. So you are having here the compression and rarefaction. So this is going to come under longitudinal waves. So this is how the wave is traveling. Okay, so this is how the wave is traveling. Same time the particles also moving forward and backward. So that means, children, the particles are moving parallel to the wave motion. So that's why we call this as a longitudinal waves. Okay. Okay, children, prayers are going. Give me some time. After that, I'll continue. Okay, children, let's continue. So I was explaining you all about the longitudinal waves. So here you are going to have the particles of the medium is going to move parallel to the wave. Okay. And then when you take the transverse waves, children, look here, they are moving the slingy up and down. When they move it up and down, this is how you are going to get the waves. So that means, children, the particles of the slingy is moving up and down. Okay, the wave is going like this. Okay, this is how the wave travels, and the particles of the slingy moves up and down. See, when it goes up, it will become up. When it comes down only, you will get like this. Okay, this is moving up. That's why it is up. So here it's moving down. Okay, so that's why you are getting like this motion. Okay, so this is like if you see, the particles are moving perpendicular to the motion of the wave. So that's why we call this as transverse waves. Okay. For the longitudinal waves, children, we can give sound energy. Now, sound energy is there. No? So that is a mechanical waves. Without a medium, children, we won't be able to hear. Now, if anyone is talking with you, if you can hear them, actually the sound waves are propagating. How the sound waves are propagating? Through air. So if there is no air, there will be no sound. Okay, so that sound waves are going to come under longitudinal wave. Just like that, children, for transverse waves, as I told you, water waves are example. The waves which form in the water will come. Okay. Now in the transverse waves, children, you are getting like this wave, no? Okay, if you take this point, okay, this is the maximum distance. Okay, it has traveled the maximum distance in the positive side. For this point, we called as crest. Okay, for this point, okay, we called as crest. Okay, the maximum distance in the upward direction. And again, like that, if you take this point, children, this particle, it has traveled the maximum distance in the downward direction. For that, we called as trough. Okay, this is crest, maximum distance in the upward direction. This is trough, children, the maximum distance in the downward direction. So this is what you are going to get for the transverse wave. So this is the diagram. Okay, so that's all you have in the type of mechanical waves. Okay, so now, children, I'll just sum up whatever I taught so far. What did I tell, children? So what did I tell? What do you all mean by waves? Waves means a disturbance propagating through medium or without medium. Okay, so based on the medium, we can classify the waves into two types as mechanical waves, and then I told you electromagnetic waves. So mechanical waves means, I told your children, to propagate, they need a medium. So without a medium, they will not propagate. Okay. Electromagnetic waves means, children, without a medium, they can propagate. So I told you, from the sunlight, from the sun, we are getting the light and heat energy. So how does it come? In the form of wave. In the form means in which form? In the electromagnetic form. Because they don't need a medium to propagate. They will just come in through the space. Even if there is no air, okay, even if there is no air in the atmosphere, children, they can just travel and come because they do not need any medium. Okay, so again we saw in the mechanical waves, there are two type of mechanical waves, children, transverse waves and the longitudinal waves. So I told you all, transverse waves means, children, the particles will move perpendicular to the direction of the wave. And longitudinal waves means, children, particles will move parallel to the wave motion. Okay, and I told that waves carry energy, so they can transmit the energy. Now I'm saying here, now you are making a disturbance. When you make a disturbance, actually the waves will propagate. No, so that waves will give the energy to the slingy. Okay, the energy will get transmit there. Okay, transmission of energy is taking place there. So those are the things you have in the type of waves. Okay, children. Now let's go to the next part. So the next part is children, we are going to study about some physical quantities which are associated with the waves. Okay, let's see what are they. Now, if we draw the displacement time graph for a wave, okay, so usually this is how we will get. Okay, children, displacement time graph. So that means in the y-axis, I'm going to mark the displacement, and in the x-axis, I'm going to mark the time. So if I draw a graph, based on the time, if I see the wave and if I draw the displacement diagram, children, something like this I will get. Okay, like this all I will get. So this is the displacement time graph of a wave. Okay, so here, look here what's happening. So now the displacement is 0. Still the wave didn't travel. Now the wave is traveling, coming to the maximum in the positive, again coming to the 0 and going to the negative and getting the maximum value in the negative, again coming back to the 0. Okay, so this is the shape of a wave. So if you take now from 0 to, it's starting from 0, going to the positive maximum and going to the negative maximum and coming to the 0. No? So for this we called as one oscillation. Okay, children, for this we called as one oscillation. So now according to the diagram, if you see, children, I have drawn here 2 oscillations. See here, this is one, and again from here to here another one. So 2, and this is 2.5. So I have drawn 2.5 oscillation. So oscillation means you have to get a complete diagram like this. Okay, this is one oscillation. So it's starting with 0, coming to the maximum, again going to the 0 and going to the negative value and going to the maximum, again coming back to the 0. This is called as one oscillation. Apart from this, children, we'll see more physical quantities. Okay, let's see what are those physical quantities. So by using this displacement time graph, I'll explain. Okay, so the first physical quantity which I'm going to explain is, children, amplitude. Amplitude means so all these are displacement. So here I can say the displacement is 0. Okay, here what is happening? The maximum displacement. So for this maximum displacement only, children, we called as amplitude. Amplitude means maximum displacement, right? So that is the first physical quantity which you should know. So this is also displacement only. This is also amplitude only. Maximum displacement in the negative side. This is also amplitude. Maximum displacement in the positive side. Okay, amplitude means simply I can say the maximum displacement shown by the particle. Okay, so if the water waves are moving up and down, there will be a maximum displacement which they are moving. No? So that is called as amplitude. Is that clear, children? Is it clear? Amplitude. So then next one, wavelength. Okay, let's see what is that wavelength. So I told you all one oscillation means what? Usually we say one oscillation means it will start up with 0. Okay, going to the maximum value in the positive, again coming to the 0, again going to the negative, getting the maximum value in the negative and coming back to the 0. For this only I told one oscillation. No. Now you can see this distance. Okay, that means if I draw this distance is there. No. That means for that one oscillation, for that distance, children, we called as wavelength. Okay, for that we can say wavelength. Now I'll draw another diagram. Okay, listen carefully. And I'll draw another diagram. I'll draw it like this. Okay, so now I can say this is one oscillation. No, so from here to here, this is the wavelength. Okay, this is a wavelength. Okay, now children, which has, now let's mark it as A and B. Which diagram is having the longest wavelength? Which diagram is having the longest wavelength? Longest wavelength means just see according to diagram. Here see the length. See the length. This is high. So this here the length is very small length. So here, children, here the wavelength is high. So that means I can say this wave is having the longest wavelength, and this is having the shortest wavelength. Okay, so that is wavelength. So simply, if you take an oscillation or if they give you a diagram, just check how much is the length. You can take the wavelength like this also. I'll draw another diagram. Okay, listen carefully. It's easy. Okay, I'll draw it like this. Okay. Now, I'll start up from here. So, what is the name I told you all for the maximum particle, children? For this point, I told you all as crest, no? When they achieve the maximum point, for that place we called as crest. And like in the downwards, I called as trough, right? So, you should know these two names. Now, children, I'll start up from here. Okay. From here to this place. Okay, another crest. Okay, if I take a distance between two crests, okay, distance between two crests, that also equals to the wavelength. So I can take from 0 to this 0, that is also wavelength. Or as children, the distance between two crests, that also give me the wavelength. Or else I'll take the distance between the two troughs. That also wavelength only. It will be the same. So from look here carefully. From here to see here, from here to here also I can take. That is also wavelength. Or I can take the distance between two crests. That is also wavelength. Or else I can take the distance between two troughs. That is also wavelength. Everything will be equal. So in case here, if I get the wavelength as 20, here also I will get the wavelength as 20. Here also I will get the wavelength as 20. It will be equal. Okay, children, did you all understand that part? Is this clear? The wavelength. So simply, according to the textbook, children, they have given the definition for the wavelength. I'll read that. They have given the distance between one particle and the closest next particle taking part in the wave motion having the same state. Now see here, if I take this, children, what is the state of this? What is the state of this? That is in 0. Again, if I take this one, that is also in 0. Okay, so closest next particle. Okay, so this point I can't take because it is not stopping in the 0. No, it is keep on going. It's going to the negative. That's why crossing here. So both are in the same state. No, both are in the 0. So that's why I'm calling this as wavelength. Or as children, if you take the crest, this is also crest. This is also crest. So the distance between two crests. So that means it is having the same state. That is also wavelength. Or here, this is also trough. This is also trough. The distance between the two troughs, that is also coming under wavelength. Okay, so this is the other physical quantity which you have, right? So children, this is my number 0749715. If you all have anything to clarify, you all can send me a WhatsApp message to this, okay? Right, okay, I'll explain. Some are asking to explain the wavelength again. I'll explain it once more, children. Okay, now I'm having a wave like this. I'm having a wave like this. Now, children, look here. Now, if from this point, okay, I'm going to take this point. From this point, okay, I'm going to take a point which is having the same state. Same state means now this is in 0, no? According to displacement time graph, this is in the 0, no? Again, this portion, this one also in 0, okay? So the distance between these two states, listen here, the distance between these two states is called as wavelength. Okay, you can take it. This is one way to take the wavelength. So that means you can say to complete one oscillation. If you take a complete one oscillation, that distance will give you the wavelength. You can take it like this. Or as children, what can you do is, now again I'll draw another diagram. Look here carefully. So here, I told this is crest, no? I'll take another crest. Another crest means just after that. Okay. Consecutive crest. Okay. Just after that. Consecutive crest. Okay. So if I take the distance between two crests, that is also wavelength. That is second way of taking the wavelength. Or as children, again I'll draw another diagram. Okay. So here if you see, this is trough, no? This is trough, no? And I'll take the closest another trough. So the distance between this trough also a wavelength. So there are three ways. You can take it in this way, like one oscillation, like that also we can take a wavelength. Or else the distance between two crests also wavelength only. Or else distance between the two trough also called as wavelength. Okay. So is that clear, children? Yes, the class will finish at 7 o'clock because it is 1 hour class. Okay, do you have any doubts in that, children? Okay. So then let's go to the next one, period. So let's see what is this period. Okay. Now look here. Now, what did I meant by the oscillation? Oscillation means this is how it should come, no? Usually start from 0, coming to the maximum and going to the negative and coming back to the 0. This is oscillation. So let's take to complete this, to complete one oscillation. Listen carefully. To complete one oscillation, let's take this wave took around 4 seconds. Okay, it took 4 seconds. So that is called as period. Period means, children, the time taken to complete how many oscillation? To complete one oscillation. Yes, oscillation means oscillation means only I told you all. From starting with 0, coming to the maximum value, going to the negative maximum and coming to the 0. So this shape is there, no? For that only we called as one oscillation. So if it is a wave, you should have this. This is a complete wave. That means one oscillation here. Okay. So here I am saying to complete one oscillation, this wave is taking 4 seconds. That means that is the period. Period means simply, children, we can call the time taken. The time taken to complete one oscillation. So let's take another one. So now I am saying there is another wave. So this took around, so this is one oscillation, no? Look, this is one oscillation, no? Starting from 0, coming to the maximum in positive and going to the negative and coming to the maximum in the negative and coming back to the 0. So this is oscillation, no? So I am saying to complete this oscillation, it took 2 seconds. So that means the period of this wave is 2 seconds. Period means what, children? Time. Time taken to complete one oscillation. Okay, time taken to complete one oscillation. Okay, now I'll give you all a question. Look here, it's easy. Okay, now I'm giving you all the displacement time graph. Okay, here I'm marking the displacement in the x-axis and I'm going to mark the time in the y-axis. Okay, now I'm going to draw the diagram. That means I'm drawing the oscillation. So here I'm saying it is the time is around, let's take it as 10 seconds. Okay, 10 seconds. Here the 0. Here the time is 0. Now here the time is 10 seconds. Okay, so they have given like this. Now my question, children, what is the period of this wave? Find the period of this wave. What is the period, children? That means to complete one oscillation, how many seconds does it take? What is the period? Think carefully. Yeah? Period means I told you to complete one oscillation, how many seconds it takes. Okay. Oscillation means what? Okay, now we'll see how many oscillations are here. Okay, let's see how many oscillations. Look here, children. The waves are starting from here. 1. Okay, this is one oscillation. Okay, here to here it is one oscillation. Okay, here 1. And again, this is the second one. How many oscillations are here, children? How many oscillations are here? There are 2 oscillations. So, children, to complete 2 oscillations, how many seconds it has taken? 10 seconds. Period means what? For one oscillation, how many seconds will it take? For 2 oscillation, 10 seconds means for one oscillation, how many seconds, children? It is 5 seconds. That means, children, the period of this wave is 5 seconds. Period means, children, you have to see for the one oscillation. Here I have 2 oscillations. No. Now I'll give you all another question. Okay, I'll give you a question like this. Okay, a period of a wave is 3 seconds. Okay, now I have given the period. Period of a wave is 3 seconds. Now my question, how many seconds? Okay, or what is the time taken? Listen carefully. What is the time taken to complete 5 oscillations? 5 oscillations. So I'm saying period of the wave is 3 seconds, and I'm asking what is the time taken to complete 5 oscillations? Okay, very good. Let's see. Many of you have sent the answer. Look here. Period means what, children? For one oscillation, no? Period means the time taken for how many oscillation? One oscillation. One oscillation means something like this. This is one oscillation. Okay. How many seconds? 3 seconds. Now I am saying 5 oscillation. 5 oscillation means like this. You have 5. Here 1. This is second one. Here the third one. Here the fourth one. Here the fifth one. Now I have given for one oscillation 3 seconds means, then for 5 oscillation, how many seconds? 15 seconds. Why? 3 multiplied by 5. 1 is 3, 5 means 15 seconds. So that is the time taken. Are you clear with this, children? It will understand. Are you clear with the period? Okay. For period, we give the letter as capital T. Okay. For period, we give the letter as capital T. And for the wavelength, children, I taught you 3 physical quantities. The first physical quantity is, children, amplitude. Amplitude means, what did I tell? The maximum displacement. Okay. Maximum displacement only we called as amplitude. Okay. And then second one I told you, wavelength. So wavelength means, children, I told you the distance between the closest particle which are having the same state. Okay. So that means if I take this diagram from here to here, I can say it is a wavelength. So for wavelength, children, we give the symbol as lambda. Okay. For this, we called as lambda. Okay. You should know this name, lambda, the symbol. And period means, children, to complete one oscillation, the time taken to complete one oscillation, that is called as period. So we give capital T. Amplitude means the maximum displacement. This maximum displacement is then a maximum displacement, that is only called as amplitude. Okay. So these are the 3 physical quantities which I have taught you all so far. So we have the frequency and speed. I will be teaching that on Sunday. So children, today is the only day I am doing it as a free session because this is grade 11, my theory class time. So my grade 11 theory class is on Thursdays, 6 p.m. to 7 p.m. and Sunday morning, 9 a.m. to 10 a.m. So if you all want to continue permanently, you all can join. So these are like 2-hour class per week, but I have split that 2 hours into 1 hour and 1 hour. So today I did it as a free session. So the remaining part we will be doing on Sunday. So if you all want to contact me, you all can send me a WhatsApp message if you all want to get my class details. Okay, children. So then and there I will be scheduling free session. Okay, then and there I will be scheduling the free session, children. So if you all want to get my updates, please join in my group. So if you all wanted to join in my group, children, you all can send me a WhatsApp message so that I will add you all in the group. So in the group, you all will get my updates. Okay. So this is grade 11. So monthly 1,000 rupees. That is the fee. Okay. Likewise for grade 10 also, you all can join if you all want. Okay, children. So that's it for today's class. So we'll wind up today's session, then we can continue the remaining on Sunday, coming Sunday. Okay, then children, bye, assalamu alaikum, take care.